Alright, in this video we're going to be creating the model Mania. This says 2010. I thought it was for 2000. Either way, this is a part just from the SolidWorks World competition, so we're going to be doing it in FreeCAD. So the part itself has two flanges. These are pipes going straight through, and then one pipe over here, however you want to call it. I'm going to refer to this as the pipe, these as the flanges, and this feature down here as the shoulder. So we've got most of our dimensions here. The only one that I think is missing is this length, how far out it goes here on the pipe. But I don't think that's going to get in our way too much. So with that being said, hop over into, let me see here, sorry, FreeCAD. And I'm using FreeCAD 1.0 release candidate 2. I already created a file, no body, so let's just create a body called body and start off by sketching a master sketch. Actually, and in fact, let's first just call that master sketch front. In fact, no need to specify that it's a sketch. Master front. And that one is, before I get into that, I wanted to create a spreadsheet. And the spreadsheet is just going to have our dimensions because we're going to have certain things referenced in multiple places. It's probably not absolutely necessary, but it's reasonably good design practice. So let me clear off some stuff here. I name my spreadsheets D so I can refer to them quickly. We pop that open and look back at this window. Let's pull it over here and pop this off to the side here. Oops, it's off screen. Come on, guy. Okay. So, to start off, I'm going to just create my legend. Get rid of that. Top level is going to be TL. We've got a dome in the center, so I'm going to say dome is DM. We have a pipe and a pair of flanges, and that's going to be PI and FG, and then the shoulder, which is going to be SH. And this is just for my reference later so that I can refer to things and kind of get things started when using the autocomplete. I don't think that there's anything else. I think those are the main ones, right? Alright, cool. So the idea here is we'll just start using different dimensions, listing out the different dimensions, things that we might want to change later, and try to come up with anything that's going to be specifically things that are shared. So we've got a top level height. Let me call that TL height of 3.35 inches, and it looks like the units are actually set to millimeters. Go up to the file, and down in the unit system, let's change that to US customary. There you go. And I'm not going to worry about aliases yet because I'm going to use a macro later that will automatically put this name into the alias here. Alright, so top level, we have a height. I think that's going to be the only top level dimension. We also have the dome inner diameter, the dome outer diameter, which is probably best done as a thickness. That should be fine. I'm trying to see if there is... I think this radius is already going to be constrained. So if there's nothing else that I want to do with the dome, that should be fine because the top level height and the dome thickness will take care of all of that. Alright, so then we have the shoulder. So we have a shoulder diameter, a shoulder thickness, and a shoulder Y offset. And let's fill some of these in. So this one, this dome inner diameter. Actually, let's do the dome outer diameter because then we can just plug it right in. 2.7 inches. The dome thickness, 0.25 inches, 1/4 of an inch. The shoulder diameter is 3.75 inches. The shoulder thickness is also 1/4 inch. And then the shoulder offset is also 1/4 of an inch. That should about do it there. And then this cross section is AA, which is right here. So that's one of the flanges. And so we actually get the flange length, and I'm going to call this the length because it's from the center, and we're going to be sketching from the center anyway, so that will be just fine. So let's start doing some flange dimensions. The first one is going to be the flange height, then the flange length. The height is here 2.23 inches. The length is going to be 2.75 inches, and that's 2 times its share between the two flanges. That's the main thing there. These we can actually just fill in the sketch probably. I don't think there's any harm in not having these be shared. And then the pipe, kind of the same thing. So I think we are pretty much set. Yeah, you know, and the flange probably didn't need to have these dimensions in anyway. So either way, whether we use it or not, we've got these dimensions. We could keep going. Things that we're going to want to change later. I suppose because there's 2 parts to these. One is stage 1, and then we get a stage 2, which is the engineering changes that you're supposed to be making. And we could kind of cheat by saying that we know what things are going to be changing, but let's try and not. Well, alright, in for a penny, in for a pound, I'm going to go ahead and start filling in some more details like this. The flange profile, I don't think I want to actually have in there, but the pipe here, I do want. So the pipe has a center outer height, so let's call that pipe center out H, and just hope that we remember what that means. 2.35 inches. Pipe angle, that's 6 degrees. You can leave that as just a 6. Pipe outer diameter and pipe inner diameter, that's 1.2 inches and 0.82 inches. And that is it, but there's one dimension that's unspecified, which is this length here. And if we look at, for example, this top view, the flange length is 2.75 inches. So rotating that around, I'm going to say that we are at roughly 2 inches, just to have something written down. So pipe length, and that's going to be the length from the center at 6-degree angle to the face. And that is going to be 2 inches. Alright. This flange, that should be pretty straightforward to actually fill in. So let's do that macro. Select all these. Come up to the top. This macro is called Easy Alias. What you do is you select, in fact, I don't remember. Let me double check. It might have a hint. It doesn't. You might select just the dimensions, or you select everything, or you just select the names. So let's see what it does. No spreadsheet selected. I disagree. Maybe I'll save first. Easy Alias. No spreadsheet selected. Hold on. Spreadsheet. Macro. Recent macro. Easy Alias. Alright, good. So you select the names. I needed a little refresher. You select the names, and now it applies, if you look up in the top right here, an alias for each of those dimensions so that we can refer to them later. Alright, so that's it. Let's get started with the sketching. I'm going to do a pair of master sketches, just kind of not super necessary, but if this was going to be in an assembly or something, it could be helpful. So they won't be too complicated, and everything's going to come along really easily after that. So let's start off. I'm going to just most of the time be using the key commands. So a lot of these have a preface of G for geometry. For example, GC would be create circle by the center. So I'll try to be using those, and also using different shortcuts for constraints, like C for coincident, P for parallel, T for tangent, S for symmetric. Those are the ones that we're really going to be using. Alright, let's, I call this the multi-line, even though it's actually the polyline, but multi-line, it has GM is the name for it. So going into that, hence M multi-line, we can start off with just going up vertically, and then press M 3 times, bring that there, press M twice, bring it back down vertically, and we're good like that. We can remove redundant constraints by just clicking to select them and pressing delete. These I'm going to use GN to turn into construction geometry because I actually want this to be here so that we can have the shoulder. And we'll bring that up. That's done. And then the same thing on the other side. And we're done. Alright, let's remove the redundant constraints. There's just one more. Happy days. This was supposed to be vertical, and that's probably redundant because we're actually going to make these symmetric across the center line, and make these equal. In fact, what I might do instead of having a symmetry constraint is just make these two equal. It looks like this is not actually vertical, so let's just toggle V on that one. Good. And for this, I'm going to select these 2 points and this center line here and press S to make it symmetric, reduce our redundant constraints, and now we've got that set. This is still not actually symmetric, so maybe I will go ahead and click those, remove redundant constraints, probably one of the equals, and we're good there. So now we have our basic shape. We could also use the pipe, and the pipe is going to be drawn, I'm going to draw it from the center, bring it out, come back, and bring it down here. Remove redundant constraints, because that multi-line polyline does not actually remove constraints. There might be a way to fix that. But let's do a normal constraint here and a parallel constraint here. I don't know if there's a particular best practice for whether both of these should just be normal, or one normal, one parallel, or maybe it doesn't matter. Either way, GN and GL to start a construction line, and what we want is just a horizontal line here, and I actually also want this center line, so that's a center point, and I hope that that is the correct, yes, okay, good. So that center line is going to be actually visible later. So now we've got this nicely constrained, and this line and this point here can be coincident, remove any redundancies, because then select both of these, press KA to do an angle constraint, and we're going to set that equal to, and now let's get into some spreadsheet dimensions. So this is the pipe PI angle, that will be 6 degrees. Alright, solid there. This line here, that is going to have a dimension, so press D, and then that's going to be equal to D dot pipe length. There's that. The distance from here to here, press D. And try and get that just centered in. Uh-oh. Let's see if I can do that better. It might require that I don't do that, but instead do a construction line. Also, so that this isn't just kind of floating out here, I think I'm just going to make that coincident. Just, it's fixed in place now. Good, right, so if I go to a construction line and bring it down like that, and make it normal here, and make it normal here, remove any redundancies, press D, let's try and get that set, there we go. I don't know exactly why it's failing with the other one, but either way, this is going to be the outer diameter of the pipe. Alright, that should be good. Let's fill in some of the other dimensions. This point here can be coincident on there. Make sure that it's fixed, because then we're going to click it and press I for a vertical constraint. Do equals D dot top level height. And there you have that. The point here, that has press I a dimension of d dot pipe center out height. So that's the external center height, which is just like so. And now our pipe is fixed. Let's go from here to here, right? Press L for a length constraint equals d dot dome outer diameter. And let's pull this out a little bit. We've got the height here, press I, equals d dot shoulder y offset. And then this line here, press I, that's going to be d dot shoulder thickness. All right, and finally, if I click this and this, press L, I can set those to be the shoulder diameter. All right, I believe we have everything constrained at that point for the front sketch. We can get out of it. Our master front sketch looks nice. We can actually use it if we want to have a datum line. That's why I included that center line. We didn't put in the wall thickness for right now. It wouldn't be a huge deal to put in the wall thickness. Sorry, I just hit my microphone. Might as well throw this in. I'm going to just drop these and make them parallel with the lines that are next to them. That one and that one. And then we can do what I might end up doing is seeing if I can constrain it. Whoops. Press the wrong key, constrain it on this, and make this a dimension constraint. Good. That is the pipe thickness. So that's going to be, instead of inner diameter, d dot pi outer diameter minus d dot pi inner diameter divided by 2. And we're good there. And then, you know, I would like to be able to just set these equal, but for right now, GUI to add another point, make that point coincident here. It's so simple, just fix this. Pull that in, equals, same thing, d dot pipe outer diameter minus d dot pipe inner diameter, all divided by 2. Good. All right. Let's get back to our part design workbench and make the other master sketch. And the other master sketch, to some extent, I mean, if we're doing this, we would want it also on this same face, which is kind of counter to what a master sketch would usually do. But we just really want to draw the flange. We don't need the rest of it. So frankly, this might be the only master sketch that we use. And I think that might just be okay. Yeah, so let's give it a try. Let's keep that as our master front sketch, and we'll see how we use it. Because we only have one body, sometimes what I'll do is I'll call this master, and then I'll use a carbon copy to put the master front into every other body. But in this case, body is an apt name for the only body in this Model Mania problem. So let's create a sketch, XZ plane. We're going to do a revolve. So bring in external geometry here, bring all of that, and we're not going to just yet do the actual shell, because my thinking is it'll be a lot easier to do the shell last, after everything else is done. That way we don't have to play with depths of extrudes. Everything can be extruded out from here and just sort of be a bit easier. So let's do a multi-line and just draw here, M. Oh, no, there you go. Click that, MM to get back, and then we're just going to trace these out, like so. Good. And then we are going to do a revolution. Vertical sketch axis is good, everything's fine. I like it. The pipe, because it's at an angle, instead of doing like a datum plane or something, I think it might be easier to just do a revolve and then select this line. Let's do a datum line along it, just so that we've got some sense of, like this is properly a construction line. And then we can actually just do another revolve around it. And that might work. By the way, I'm going to call this dome. It might not exactly, so I'm curious to see what happens here. But I'm going to create a new sketch on the XZ plane, pull in our external geometry as a pipe, and part of me thinks actually, let me click the section view so we can see on the inside, like that. Part of me is thinking that we'll also save these holes for last, because I think later we're going to run into some issues with the holes when we get our flange coming out at a 45-degree angle, and it's going to overlap. So with a little bit of foresight, I'm just going to use the multi-line tool and drag out. Let's do it the other direction. Come up here, click there, there. And I didn't draw that line all the way in, so we'll just get that in a second. Pull that in. Add a center point there. This one also didn't have a center point, so this point we can actually automatically do symmetric. Let's remove the redundant constraints and another redundant, and then finally make that coincident there. Good. Escape. Got that sketch selected. Let's revolve, and instead of doing that, we are going to select our reference as this line here. Voila, we have our master sketch front filled out, and all that remains is the two flanges. So looking back at the drawing, we have one flange at 90 degrees to the pipe and one flange 45 degrees in the center. So we're actually just going to do a revolve with a few features to bring that in. So without further ado, let's sketch on the same plane, and this time we're just going to be drawing so we can really hide everything that we've done so far, including the master sketch. Actually, we want to keep this top level dimension, and just clear that out. Start drawing this overall shape. So I'm not going to bring anything in quite yet, unless it lets me pick up. It does not pick a point, is what I was going to say. So let's pick a point on this. Good. Coincident. That's our center point. Very, very nice. All right. To draw the other thing we've got, I think what I want to do is not have a master, but just go straight in. But something that you could do is this. So we'll draw these two bores and then this main through hole, and keep these just because I don't think this is ever going to change. Keep those symmetric about that center hole. We'll bring up our image again. I wonder if we'll have enough space to fit in like this, and I will just auto hide that and auto hide this. Now we get a little bit more space and we can actually see our dimensions. Let's quickly hide that because we don't need it anymore. Alright, so this KO for a diameter constraint, that's 0.38 inches. We have the center, which is a diameter of 0.75, 3/4 of an inch. I accidentally did a double thing there, but that's fine. And then this one and this one are equal, and they are already symmetric, and their center to center distance here, if we pull it in and do I, that's going to be 1.5 inches. Get that off to the side, and this is pretty much done. So all we have next is a couple of these rounds. So this one has the center here, this one has the center here. So because they're all concentric, that's going to make our lives a little easier. Bring that out, make it concentric on that arc, Gotcha. Right. All right, that's fine. Let me make that better. We'll just do it manually in a second. This is going to be like the same thing. We'll do the symmetry later. This one goes around here. This one goes around here. All right. Keep some symmetry going. Let's make that symmetric like so. And then this one. I don't know if I can do a symmetric point like that. I think, yeah, it'll just cause an error. So let's do, horizontal line, symmetric line, just so that we don't have to worry about dimensioning things. Where's my thing here? Remove any redundant constraint. And we can't move it side to side, so just, the construction geometry, it's not exactly a center line, so I just stress about how it goes. It doesn't go on forever. Anyway, this we want coincident on there. This point is now fixed. Oops, we have redundant constraints. Let's see, this is now going to be, well, let's just one thing at a time. Make this symmetric. And this one and this one are symmetric about the center. Again, remove our redundant constraints. And make that coincident with the top, which we can see from, for example, here. It is coincident right up on the top. All right, KR, set some radii. That is 0.38 radius inches. And this are going to be equal. One more time. Delete that. That might have been the equal constraint because it's actually thoroughly unnecessary. This from top to bottom is going to be symmetric. This from top to bottom is going to be symmetric. Let's remove the redundant constraints and the redundant constraint. GN, GL will pull in, I don't know if I got that exactly, these lines. Let's get that. There you go. And we just got one last thing to do here, which is a tangency. Tangency. I don't think we need the tangency over there. This one's tangent. Some of these symmetric constraints will help us out here. Alright, KR, that is 0.61 inches. This and this are equal. Let's see how we're doing here. We just want a tangency constraint there, and we're good. Okay. Kind of a wacky way of doing all the constraints, but it's alright. We got there. So this actually is really just like a master sketch for the flange. The only thing it references is this top level height. Something I might actually do is delete this, and now this moves up and down. Press I, and set that equal to d.top level height manually. That way we're not depending on any external sketches or geometry. And that's that. So we can hide that, bring this back to full screen. I'm gonna, whoops, I didn't mean to dock it. I just meant to change it so it doesn't auto hide anymore because I like being able to see it. None again. Revolution 1. I'm going to call that pipe. We've got our sketch here. VT will toggle transparency. And actually, if I just hide this and select only the outer lines, this is one of those nice improvements from the latest version. We can pad just that part, and equals d dot flange length. We didn't actually need the flange height. Flange length, that's set. We're good. We have our flange. None of the holes yet. That's going to be fine. I'd done this before this one, and I know that this point at the top is going to cause some headaches later on with the fillets, but it's pretty much just like, I'd rather see it when we actually approach it. it's a little more realistic. Right, so if we take this pad, which I'm going to call flange, we'll call it flange 1, we can pattern this. Bring this out a little bit more. Instead of the normal sketch axis, we're going to do the base Z axis. And instead of 360 degrees, we're going to do 45 degrees. Reverse the direction. And we have our 2 flanges. And I feel like that 2 inches was probably too much on the pipe. And so if we go back to our spreadsheet and find out where that 2 inches, let's change it to 2.5. That's better. That looks a little bit more like what they had in the drawing. Alright, so our pipe is in, our 2 flanges are in, we don't have any holes bored, but that's kind of a good thing because then we don't have things overlapping with each other on the inside, and it just seems a bit neater. So, next thing we can do, take this sketch, hide everything, just do the full bore all the way through, pocket that, through all, reversed, that way it comes through. So that just goes straight into the center of the dome. Take that pocket, call it flange bore 1. Take this polar pattern, call that flange 2. Select this, pattern it, do the same thing, base Z axis, 45 degrees, reverse direction. Good. And then we're going to have a similar thing with the pipe. If we look at the master front, we can, oh, and let me call this flange bore 2. We could do another revolution like a groove, and that might be just a simple way to avoid like datum planes and whatnot. So let's do that. XZ plane, reference external geometry, bring these lines in. We already have our datum line in there. So multi-line, click, click, and we've got our sketch. Let's just make sure it's good. And then this sketch, let's make sure the datum line is visible. This sketch will be a groove. And we're going to select reference and choose that. Oh dear. It looks like that broke the model. So, what happens if I undo the reverse, symmetric to plane? None of that's going to work. Did that say revolution or did it say groove? Well, it's all going to be the same. Wire not closed. That could be a hint. Let's do this. And if that wire's not closed, it could be the fact that this is not actually normal to everything else, including our line. That's, I suppose, possible. Why don't we just avoid that possibility? GN to make that a construction line. I just don't feel like deleting it. Click this, bring it down. This and this, normal, escape. Let's try and groove that again. This time. And it says wire is not closed. Select reference. And select that. So there must be something that, oh, yes. That makes sense. And make sure all of my constraints are visible. Whichever one is telling it to be coincident on there. That's the one that I want removed. GN just to avoid deleting. I find that deleting can delete constraints and it can be a bit of a bother. So that's fine. Alright, sketch 4. This time, hopefully, we get something that works. Not this. Select this line. And again, it is not, it's really not liking that. Alright, well, we tried. I'm not sure why that's not working. Actually, yes, I am. People watching must be screaming. This line we actually can't delete because we still have that construction geometry. This can be deleted, this one, and this one. We don't actually need, we're only supposed to do half the thing, so let's bring that in. Alright, we're working through it. Just tried to make everything go get that, coincident, escape, revolve, groove, and then instead of that, select reference, select that one. You know, and it's still really not liking it. At this point, I'm not sure exactly what the problem is. One last thing, and I feel like this is such a typical thing of not only like FreeCAD, but also just learning CAD in general. Let's draw this. Make sure that you just don't make silly mistakes. Make that normal by pressing N. Go back in. Make this construction geometry because we are just going to take this and we're going to keep everything like so. Alright, select that. Take this, groove it, reference here. Nope. Well, you can't say we didn't try, and there could be some stupid mistake I'm making at this point. So, such is life. Whoops, I almost deleted that instead of hiding it. So instead, I think I am going to go in and do a sketch on the YZ plane. And I'm just going to quickly draw a circle, because I want to see if we can adjust the attachment of the sketch and change the axis to be equal to d dot pipe angle. And we'll see, instead of we want the sketch's x-axis. So that should be that one. We can be 0 on the z-axis. And we get something that is, in fact, attached without actually referencing any actual faces. So that's just nice, avoids any issues. Let's get back into the sketch. Now we're looking up, down, up into the whole thing. And we can turn on section view. Right. The one thing that I think we want here is this point. So let's reference, hide everything. Let's reference that, because that is our center point. Now, is that going to, this is, of course, the question, is that going to project it horizontally, which I think it will. So it's actually not going to be quite on. No, well, yeah. It could be all right. Let's see. Yeah, no, that is what we want. Okay, good. So this bore circle, coincident, shrink it down, KO equals d dot pipe inner diameter. Close that, pocket, through all, reversed. Ugh, now we've still got issues, and I'm not even sure what the issue is. Yeah, because this pocket should be fine. Please do show direction. Let's toggle transparency of that, make sure that the pipe is there. It could be the fact that the pipe is intersecting with other objects so that it's not really fully into the solid, but I don't think that that is the case. And I did not expect to have so much trouble getting this to just pocket. Let's delete that. Let's go and make sure that there's no complaints here. I'm just trying to move things to see if it'll auto update, but it doesn't look like it will. So pocketing, again, VT. It is going somewhere, but it's really unhappy about what what it's doing. If we go the other direction, it is just first really having a fit. Alright, delete that. Our sketch is really struggling. What we might be able to do is, instead of having the attachment through here, we are, let's make that 0. And just out of curiosity, if I pocket this through all, will it actually do the pocket? It won't. So it's quite unhappy with that. So take this sketch, go to the attachment editor, and click that point there. Oops, now click that point there. Alright. It's offset, we can fix that. I think that'll be okay. Oh, actually, nope. Now it's back where it's supposed to be. Alright then. This time... Oh my goodness, look at that. I'm not sure what is breaking the geometry so much. I wonder if it's something silly that I'm doing. But it seems pretty straightforward so far. I mean, this last one is the most, arguably the most flawed. Let's take this, delete it. And I don't want to switch into the part workbench because mixing these two workbenches can be a problem. So let's create a sketch, another sketch on the YZ plane. And similar to before, I'm just going to draw a quick circle. Not even going to have it on the main line thing. That circle's there, and we want to change not only the angle of the sketch, but also its position. So let's take the position, change the Z equals D dot pipe length. And that's got to be negative because we're on the other side of it. And then for the angle, D dot pipe angle, and that is on just the x-axis. Okay. So now we've got something, and that distance is actually, that's actually from the center at 6 degrees. So we might need to do a little bit of calculus. So escape. In fact, before we even try that, it would probably be worth it to try and do a hole. Oh, good. Okay, we have at least some hope. Alright, so if that's 6 degrees, and we're just looking at this, the position is not equal to the length, but the length times the, what is it going to be, the cosine of d dot pipe angle. I don't know if it's the, because it's supposed to be, the hypotenuse is here. We want the horizontal leg, and the cosine is the opposite, or the adjacent over the hypotenuse. So then hypotenuse times the cosine should give us what we want. It doesn't look like it did. Well, what am I doing wrong? I think I'm just going to take a second and figure this out, and then come back to it. Okay, sorry, so the issue there was that let me clear this. If we have the sketch, as we change this angle, it's actually rotating around the origin of the sketch. And we want it to be rotating at around its center point here, which is located at, let me just fix this. Oops, I meant to resize it like so. So change the Y position to the pipe center out height. And that way, if we look at this from the side, it now lines up very nicely. The horizontal length, depending on the way the transformation is applied, it might be okay. And either way, it doesn't have to be exact. But let's take this, bring it down roughly. We actually, this is kind of lucky, want this right here at the origin now, because we did that in the sketch attachment. And yeah, this is actually supposed to be, if we want it right on the face, that negative this times cosine of d dot pipe angle. Hello. Double. There you go. So that's where that trig would come in. Anyway, coming back to here, change this KO, and that's going to be equal to the pipe inner diameter. We're done with that. And maybe we pocket this reversed. There you go. Okay. Equals d dot pipe length, and that's at the right angle, so that should go straight into the center. And after much trouble, we did in fact get our bore. So I'm not sure exactly what was going on there. I'd be interested to try and dig into it a little bit more, but not interested enough to, you know, bang my head against a wall. Let's call this pipe bore. Funny that the most difficult feature was just a hole at 6 degrees, but we learned that you cannot do it from the center. You can, however, do it from the outside. So we've got our geometry here. There's one last thing, and that's going to be on the XZ plane. Do our section view and show me this sketch. Oh, you know, yeah, right. So one thing that we could do is just reference this geometry, and the other thing we can do is click this geometry and have them come out, but we can't necessarily click the geometry and have them pop out because we need them to bore in only a certain distance. So we'll just reference them. And of course, GC to do a circle. I never do the tangent constraint. It just has bitten me in the past where the constraint can flip or some such, and I don't use it. So instead I just click both of them and set them equal. 1, 2, equal, equal. Change this z-axis of the sketch attachment to be the flange length. Now they're on the outside there. Those are, I don't know if I recorded this actually, so I'm just going to fill it in. That's 1 inch. Flange, I guess they're probably like mounting holes, so we're just going to call them flange holes 1. Take that, rotate about the z-axis, reversed, 45-degree angle. Maybe it's not reversed. Oh, it was just loading. And we're good there. Let's call that flange holes 2. A bit confusing if somebody was trying to follow along, but let's hide that. We are now complete. So this is the body. We just need to do the fillets, and the fillets are real pain. Let's just see what we could try to view it and infer what's going to happen, but where we're going to struggle from the last time I was doing this is along this edge here. You just have 1, 2, 3 faces, and then additional 1, 2 faces at this central point at the top where, yeah, 1, 2, 3, 4 faces all meet at the same time. You might also get issues from here to here, and let's try it. Let's just try it. Select that, preview it. Yeah, nothing nothing's going to work there. Something you can do, actually, is fill it in between these two. Preview that. Oh, in fact, it's not even going to let you do that. Let's say cancel. Click here, fill it, nothing. So what do? We were not able to successfully fill it. And I guess before I do fill it, it's arguable that we should bore out the center of this thing. The center of the dome. Yeah, well, fine. And then I'll explain, but what we're going to be doing is just making a small pad at the top, or pocket at the top, that is going to break up some of those competing faces, and that should help us do our fillet. In any case, first we're going to hollow out the center, and to do that, we're going to click here, and like so, take this GN to make a construction geometry, do some inner lines just to show where it's actually supposed to be. Make 1, 2, 3 all equal. Set the horizontal on this one with L equals D dot dome thickness. There you go. Alright, GN and GM to start a polyline. Bring it up to here, and then press M 3 times. And now it's M twice to bring it back, and we're there. Let's delete the redundant constraints and groove. Alright, satisfied. So everything's looking good now. Alright, now like I was saying, this is dome bore. To get the fillets to work, and I don't know exactly, how to apply this more generally, but you can add a flat up here, a little circular flat bit, and that is just going to, again, break up some of these faces so that you don't have a combination of, 4 faces all at the same point. So let's at least give that a shot. And to do it, I'll just do something on the XY plane, and we'll change the attachment later. Hide everything, add a circle. And we kind of have 2 options. One is to just do this on the dome and not on the flanges, but I think let's just make something that's really big. KO 2 feet would be great, thank you. Just because I want to cover everything. Change the attachment on this to be equal to the top level height, and pocket. And then this is going to be, let's see, 0.01 inches. Let's see how low we can go before it starts having issues. There you have it. Alright, so now I think this is going to work better with our fillets. So this is, I'm just going to call it flat. Okay, let's start selecting edges. And I will try not to get too far before I test it. Oh, command not done. Oops, cancel. Come back, select just one line, fill it, command not done. Alright, that's not working very well. We might need to actually go around and select all the edges. I have some concern with the fact that this one didn't work this time, and it did work previously. I'm not exactly sure. It could be, 2 edges that are a little bit close to tangency, but not quite. Let's see now if I do this. I'm not sure, it might freeze. Nope, it's not working. Well, that's going to be a difficult one to fake, and I've had this work before with this little flattening trick, but it looks like this time around we're not so lucky. I do wonder if maybe I misdrew something, but for now, we might just be at the end, and this has already gone on for probably an hour, so we can suppress that last feature if we want and get rid of the flats, because we are not going to be doing any fillets. It's just frustrating. Alright, well, there's only one thing left to do if we don't have fillets, which is to start from here and then go to stage 2 and see if we can get this to change. So the differences are the outer diameter of the dome is now 3.4 inches, and the top to center height of the pipe is now 3.5 inches, and the top level height is 4.5 inches. So these are fairly large jumps if we look back at our spreadsheet. The top level height now is going to go up to 4.5 inches from 3.35. Let's tile these windows so we can see both. If I just jump this up to 4.5 inches, I am actually surprised. Nope, it did work. What I've seen before is that it will break the model. I guess I was sufficiently careful enough this time around, but it'll break the model whether it was references somewhere, and what you have to do instead, it's because of constraint flipping within the sketches, so what you have to do is kind of step it up gradually. The other one, this pipe center out height, that is now 3.5 inches from 2.35, so let's see if we can just jump. Yep, and that worked just fine. And then the last change, 3.4 inches, and that is the dome outer diameter. I'm going to save now, but while it's still functional, I'm just going to go right in. Yep, look at that. Okay, so we've got our new model. Again, the fillets, they're going to be a problem, especially probably around here. But otherwise, we have completed Model Mania for the year 2000, parts 1 and 2. So hopefully this gives a sense for what modeling looks like in FreeCAD 1.0, including, as we saw, some of the issues that definitely pop up. So thanks for watching, and cheers.